Hi and good morning everyone. Before I start my presentation, I would like to thank you personally for taking your time and effort to come and watch my presentation. So here I am today. I'm Fauzi Akbar and today I will talk about how to build an AI technology that loves watching videos and automatically generates a video trailer. So please sit tight and enjoy the presentation, and hopefully you will learn something new and exciting today. Before I jump into the main topic, I would like to talk a little bit about myself. Currently, I'm a technology graduate at carsales.com. And at carsales.com, we provide a platform to help in buying and selling cars from various sources, including private and dealer cars. And at any given time, we have approximately around 230,000 cars, and that includes the 5,000 new cars coming in every day. Not only cars, we also have a platform to help in buying and selling bikes, boats, trucks, and caravans. So, as a graduate, my journey in the industry has only just started. During my time in the university, I always have a passion in playing around with big data and software development. I'm also very lucky and fortunate enough to work at a company where they allow me to apply my passion. I would also thank Agustinus Nawan as the head of machine learning and AI team at CarSales, as he inspired me to use my skills and knowledge in the AI technologies areas. Now, let's jump back onto the main topic on how to build an AI technology that can automatically generate a video trailer by only watching the video. So here is a little background information. CarSales recently just released this feature that allows users to upload a video of the car that they're trying to sell on the car sales website. This is what we call the user-generated video. It is believed that the user-generated video, or UGV, has helped improving the car buying experience, as it adds another dimension that allows deeper user engagement. So for now, I will show you how car sales show the user-generated video to the consumer. So if you see on the left hand side here, this is what we call the listing page. The listing page shows all the cars that are currently on sale on car sales website. And for this specific example, I will use one of them for example. Let's just try to pick the first one here, the white Porsche. So if you click onto the ads on the website, it will redirect you to a details page. This is where we actually show the user-generated video. So if you click the play button here, it will show you the whole original user-generated video. And for now, I'll show you one example that I will use later on to create a video trailer. So please have a look at the video I'm going to show you soon and see what do you think about the video. For this example, this is a 30 seconds video that shows various parts of the car, including the front 3/4 of the car, the back of the car, and also the interior. From the buyer's perspective, this video allows us to know better about the condition of the car. And that is what we want, right, as a buyer. And now, I want you to have a think about what can we do with this video and how can we create a trailer out of this 30 seconds video. Before jumping into on how to create a video trailer, we at Car Sales, we plan to show the user-generated video on the listing page. But as you saw before, 30 seconds might be too long to be included in the listing page. Therefore, we should try to shorten the video down, and it should only include the interesting sections of the video. But there's another question. How do we know what are the interesting sections of the video? Now, I want you to keep that in mind for now. So here is the list of different sections that we saw from the previous video. There are many sections that were shown in the video, but which section would you choose if you only have 5 seconds budget? And the answer to that question is, why not only the exterior? As we only have 5 seconds, we want to show the user how the overall of the car looks. And if the user wants to know more about the interior, they can easily go to the details page and see the original video. Now, the interesting part. How do we generate video trailers? The first options I have here is the classic approach. We can hire video editors, we buy the video editing software licenses, and we let the video editors create the trailers for us. But what can be an issue here? The first big problem is time. Can you imagine? We have around 5,000 new cars every day, and let's say an average time for a video editor to create a trailer is 15 minutes. 15 minutes times 5,000 is 22,500 minutes or 375 hours. That's the time they spend for only creating trailers for 1 day worth of new cars. And if we only have 10 editors, we cannot finish the job within a day. And the only option to finish the job within 1 day is to hire 47 editors. That will be really expensive, right? And that's not including the video editing software licenses for the all 47 video editors. And that's our second biggest problem, money. The last but not least issue would be training. Each of the video editors have to do some training to perform the job correctly and efficiently. So, what do you guys think about this approach? Is it your preferable approach? How about if I tell you there's another approach which will save you a lot of time and money? And this approach, we're gonna utilize the AI technology. So, what if all we have to do is send the original video to the AI and the AI will automatically generate a video trailer? How about this? Would this be your preferable approach? Because it surely is mine. The AI technology that I'm going to talk about is called Hawkeye. And Hawkeye is the trailer generator for our car sales website. So let's get into the exciting part of this presentation. After knowing what we want to create, right? We already know what the output video should look like. But then I started asking, how does the Hawkeye pick which section of the video to be included in the trailer? What are some factors to be considered, such as how far away is the car, what is the angle of the car, and how many sections will be in the trailer? Now, let's get our hand dirty and start analyzing the video. First thing that we have to do is actually to read the video frames. In our case, I read the video frames every half of a second. The reason is that we assume that there is enough frame for us to assess by only reading every half of a second. And we could still see if there's any slight changes in the video frames, such as transition period or change of section. And each of the video frames that we read from here will be assessed later on. After reading the video frames, this is what we will have. It is a collection of video frames. And the next assessment is the really important one. What do you think will be the first assessment? First thing first, we have to know if the object in the video frame is actually a car or not, right? Therefore, this is when the Amazon recognition comes in handy. So for each of the video frames that we have, I send it to Amazon recognitions to figure out what's the actual object inside of the frame. And the Amazon recognition will return us the bounding boxes of each object they found. And in this specific example, there are two main ones they found, which is the car and the wheels. You can see there's a box here, which is the car, and this is the wheels. However, what will happen if there are more than one bounding boxes, such as these two examples? It is super simple. If they find 4 cars, for example, like this left-hand side images, we only need to care about the largest car. Why? Because we assume the largest bounding box of the car will be the main focal point of the video. So at the end, we will only have the largest bounding box. This is what we're going to be left with. Now, let's move into the next assessment. Now, as we already know where the object bounding box is, we can assess the video frames further. And the next step is to figure out what is the angle of the car. Is it the front 3/4, Is it the back of the car or is it the interior, for example? Therefore, in this assessment, we can start cropping the image into just the bounding boxes size, and we're gonna send them to Cyclops Angle. What is Cyclops Angle? Cyclops Angle is our own car sales AI technology that is helping us to figure out what is the angle of the car. Cyclops Angle is an image classification model that we train to differentiate different angles of the car. Now, all I have to do is to send the cropped image to Cyclops Angle. It will return me the angle of the car. And for this example, this is the front 3/4 driver angle. Let's move that to the side now. If you're interested in creating an image classification model like Cyclops Angle, it is super simple and easy nowadays with the help of Amazon SageMaker. All you have to do is to prepare the model training sets, which is a collection of a labeled image with the bounding boxes or where the object is. In this case, we need to specify where the car's bounding boxes is. And if you send that to Amazon SageMaker, they will be able to create a car angle object detection model. To actually create the model, all you have to do is if you go to the AWS console and go to the Amazon SageMaker, there's already a built-in SageMaker image classification algorithm that you can use. So all you have to do is to tell AWS SageMaker where all the labeled training sets are. Now, as our video frame collection already have more information than before, what do we do with this car angle information? How about if we group them together if they have the same angles and create a smaller collection? So for example, these 3 frames have the same front 3/4 driver angle, right? Now let's put them into the same collection separated from other angles, and we will have this. As you can see from this slide, we're grouping the same angles together and separating them from the other angles. This makes it easier for us to eliminate the section that we don't want to be included in the trailer. So we don't need this interior section anymore, right? Now we could just ignore them and we only continue assessing the exterior angles. The next assessment is to find out how far away is the car. In order to figure that out, I use what is called an intersection over union, or IOU. But what is actually IOU? In simple words, IOU is an evaluation matrix to measure the accuracy of an object detector. But in our case, I specify the ground truth, which is this green box here. So the green box is the desired location of the bounding box. So the higher percentage of an intersection of the car bounding box with the green box, the higher the IOU score will be. So next, we need to calculate the intersections over union for each of the frame that we have. Now, we already answered the question, how far away is the car? But after experimenting and testing, I came across this issue. What do you think happened here? There was no mistake in the object detection phase, as it was able to find the correct location of the car. And there was no mistake as well at the Cyclops angle phase, as the Cyclops angle was able to detect the angle of the car correctly. This is what I call the transition problem. In some cases, the user had already edited the video before uploading it to the car sales. Therefore, it might include some transition period in the original video. But how do I overcome this issue? To overcome the transition problem, I used another method which is called the distribution score. The transition period will most likely happen at the start and at the end of each section. Therefore, there's a really simple solution to overcome this transition problem. All I had to do is to score the start and end frame of each section with a score of 0, and score the middle section of the collection with 1. So we will have this. As you can see here, for each of the collection, I score the start and at the end frame with score of 0. Now, if we look closely to the problem that I showed before, we can eliminate the transition problem by removing them from the collection. This frame here will have a score of 0 and 0. That's why it's removed from the main collection. Then the transition problem is solved quick and easy. The next issue I came across was these partial car frames. This is a really common issue that I found with the user-generated video, where the video only shows 3/4 or half of the car. But how do I overcome this issue? As the desired trailer outcome is to show the full car in the trailer video. Before I move into on how I solve this issue, I want you to have a look closely into these two images. Do they have any similarities? And guess what? To overcome this problem, I used another scoring method, which I call the border distance score. If you realize from this slide and the previous slide, the frame that shows only partial part of the car, the bounding boxes is always touching the border. And that's the reason why I call this method a border distance score. It is a simple solution that solves the partial car frames. Basically, if the car bounding box is touching the border, I score the frame with a score of 0. And the scored frame with the bounding box far away from the border with a higher score. So for this specific example, this specific car has a score of 0.8 and the one that is touching the border has a score of 0. These 3 frames here will have a higher score compared to these 2. Let's move into the fun part. It is time for us to pick the trailer section. Let's have a look at what we have so far. This is what the frame collection will look like after we finish with all the scoring methods. Each of the frame will have its own IOU score, a distribution score, and a border distance score. The next step for us is to combine this score together so that each of the frame will only have one overall score, which will be the average of these 3 scores. So if we combine them together, we will have this. This is what the overall score will look like. The next step is for us to find how many sections do we want to be included in the trailer and how long each section should be. For our example today, I will create a 6 seconds video trailer with 3 sections, so each of the sections will be 2 seconds long. Now, for our example, each of the sections should be 2 seconds long. And if you remember what I mentioned at the start of the presentation, I read the video frames every half of a second. So to have a 2-second section, all I need is 4 frames. Now, all we have to do is to find the highest scoring group for each of the section. How do we do that? Simple. Let's group 4 frames together and combine their score. For example, let's combine score of 0, frame 1, frame 2, and frame 3 together. And do that to the other frame as well. And at the end, we will find the highest overall score. Therefore, in our example here, the front 3/4 angle section, we will pick the frame 1 to frame 4 because it has the highest score of 0.84. Now, if we do that to the other section as well, we will be left with this list, which is a collection of the highest scoring frame for each of the section. And now let's get back to our question that we had before. How many sections do I want to be included in the trailer? As we agreed before, we're going to make a 6 seconds trailer with 3 sections. So we want to find the top 3 highest scoring frame group. In our case here, the front 3/4, rear 3/4 angle, and the side view, they have the highest score amongst the group. Now we are ready for the final step, which is to combine these frames together. Before we combine the frames together, we have to read the original video again, but only for the specific time frame that we want. For an example, for the front 3/4 angle, we take the 15th second to the 70th second of the original video. Then we can start combining the sections together. And that's all we have to do. So here's the final video. What do you guys think about this trailer that we just created? It wasn't super hard, wasn't it? Let me give you another example. This is another trailer that was created by Hawkeye. So from looking at these 2 examples that I've shown to you, 5 seconds is enough to show you how the overall card looks like in more dimension than just a photo. Therefore, putting a trailer onto the listing page would be really useful to engage the user even better. Now, I will talk about the opportunities that this technology can open up. For example, at car sales. This is the car sales editorial page. Wouldn't it be nice if you hover over a text that mentions about a specific part of the car, for example, in this case, a 19-inch wheel, and the video trailer will pop out, so you don't have to scroll through the whole page to find the image that actually shows the wheels, or even watch the whole video just to find how does the wheels look like. That concludes my presentation today. However, I would like to quickly talk about the takeaways from this project. One of the main takeaways is that learning more about AI technology is a fun and exciting journey. And with the presence of Amazon SageMaker, it makes our life so much easier to develop a high quality model as the heavy lifting has been done in the backend. And that brings us to the end. I would like to thank you for your time and attention today. I hope you learned something new and useful. And hopefully, I can inspire you to join me in this AI technology journey. If you have any questions, please feel free to ask me, and thank you.